Welcome back, and we are doing notes number 35 today. We're learning something called the law of sines, and we have a little bit of prerequisite information first. So using a calculator, let's find the sine of 40 degrees and the sine of 140 degrees. So remember to check the mode on your calculator and make sure you're in degrees, not radians. Sine of 40 and sine of 140. It doesn't matter what the number is, but what matters is that these have the same answer. Now let's also look at sine of 15 and sine of 165, and I'm going to mark those two as equal. So sine of 15 degrees and sine of 165 degrees. Also equal. Let's look at sine of 1 degree and sine of 179 degrees. Also equal. So, what do you notice about these two angles? What's their relationship? And is it the same as the relationship between these two angles? And is it the same as the relationship between those two angles? And then what would your generalization be? So I would say that those two angles are supplementary. And so if one of them was x, the other one would be 180 minus x. And so my generalization would be that the sine of x degrees is equal to the sine of 180 minus x degrees. So that's important. It's part of the law of sines proof, and it's also going to come into play every once in a while when we do the problems that we have today. Today we're going to talk about solving a triangle. So what does it mean to solve a triangle? This is something that you could do for certain kinds of triangles. If you had a right triangle, let's say we have right triangle ABC, and by the way, every time I use solving a triangle techniques, I'm going to use notation where across from a capital letter angle is a lowercase letter side. So A is across from A. Side B with a lowercase letter is across from angle B with a capital letter, and side C with a lowercase letter is across from angle C with a capital letter. So you can assume that I'm always doing it that way. A across from A, B across from B, and C across from C. Now suppose we knew that side A had length 10 and side C had length 7, and suppose we knew that angle A had measure 37 degrees. I don't know, I'm just making this up. So if we knew those things, we could find the measures of all the rest of the parts. We could find the measure of side B, we could find the measure of angle B, and we could find the measure of angle C just using sine, cosine, and tangent and the Pythagorean Theorem. So that's great for a right triangle, but what we're going to do today is learn some ways to solve triangles that are not right triangles. So what about acute triangles, and what about obtuse triangles? Well, the law of sines is going to be a formula that helps us solve some of them, depending on the given information. And then next time, the law of cosines is going to be a different formula that allows us to solve some other triangles. So today our goal is to learn the law of sines. Now, ta-da, here it is. Well, that was quick. What I've decided to do is, in a separate video, I've gone through the entire proof of the law of sines. So if you're interested in seeing where it comes from and seeing the steps that go from a certain starting point to knowing this formula, you can watch the other video. However, I know that sometimes watching videos is overwhelming and time-consuming, so that's going to be optional. And for you today, all you have to do is learn the formula and use it. So, for any triangle with sides A, B, and C, and angles A, B, and C, corresponding as I described on the previous slide, side A over the sine of angle A is equal to side B over the sine of angle B. So that proportion is true. And it's also equal to side C over the sine of angle C. Now, when you use this formula, you're not going to use all three ratios. You're going to use two of the three ratios. So it depends on the problem. Maybe you'll use A over sine A equals C over sine C. It just depends on what parts you know and what parts you're solving for. Also, it's good to note that this formula can be flipped upside down, so there's nothing wrong with something like this. Sine of A over side A equals sine of B over sine B, or over side B, excuse me. Again, watch the other video if you want to see the proof. So I'm going to work through some examples, and it's going to be very important that we remember how to store values on our calculators because I'm allowing approximate answers for these problems, but if you round something and then you use it when finding something else and then you round that, you're throwing off your accuracy. So what you want to do is store numbers in your calculator as opposed to rounding. And storing numbers in your calculator is something that I plan to do with you in class today. I hope I did it. I hope I didn't forget. But if you missed it, I will briefly show you on one of these examples. Okay, we have triangle ABC. We know angle B, we know angle C, and we know side A. So what we need to find is the measure of side B, the measure of side C, and the measure of angle A. Those are the unknown parts. Now, there's not necessarily a particular order to go in. You can solve whichever one you find easiest. So I would say, because we know that the angles of a triangle add to 180 degrees, solving for the measure of angle A is easiest, 180 minus 40 minus 45. And that gives us 95 degrees. So that's the measure of angle A. And that's exact, it's not approximate. Okay, so now it's time to find side B, let's say. Let's do that next. So I'm going to use the law of sines. I'm going to use A over sine of A equals B over sine of B. And I'm choosing those two ratios because I know side A is 10 and I know angle A is 95 degrees. So you know a pair, you know A and A. You have to know a pair in order to make this work. We don't know side B, but we know angle B is 40 degrees. So in this proportion, there were 4 unknowns. 1, 2, 3, 4. We knew 3 of them, we substituted them in so we can solve for the 4th one. So to solve this proportion, I would cross multiply, and that gives us B sine 95 degrees equals 10 sine 40 degrees, and then divide both sides by sine of 95 degrees. So B equals 10 sine 40 degrees over sine of 95 degrees. Notice I haven't put anything in my calculator yet. We're keeping everything exact for the moment. Now it's time to put this in your calculator. And just remember that if it opens parentheses before the 40, you have to close them before you divide. And then if it opens them before the 95, you can close those too. So we grab a calculator. 10 sine 40, close the parentheses, divided by sine 95. I'm going to double check, did I write that down right? Okay. And then press enter. Okay, so we're going to round this answer to 6.5, but I'm going to store it, just in case I have to use it again. For some problems, you need to use things again. For other problems, you don't. It depends on the problem. Here's how we store it. See, next to the 1, there's a button that says stow. That's short for store. You press that, and then you choose a letter. So because we were going for B, I'm going to call this B. So I press alpha, and then you see the B here above the button that says apps. So I press that, and then I press enter. It repeats the number that we've stored. And then in the future, if we want to use it, all we have to do is press alpha B, and it will know the number. Okay, so 6.5 is the approximate answer. I'm going to go ahead and use my approximate symbol. Okay, so we got that part. Now we also need to find the measure of side C. So let's use the law of sines again. But this time I'm going to use A over sine A equals C over sine C. So we have 10 over sine 95 equals C over sine 45. Cross multiply. Divide both sides by sine of 95. and put it in your calculator and round to the nearest tenth. 10 sine 45 divided by sine 95. 7.1. Now it turns out we didn't have to use our stored b value, but you'll see in future problems there will be times when you do. Okay, that triangle is solved. Let's go on to number 2. This one says, find both angle A and angle C using the law of sines. So we're supposed to practice it twice. Now in problem number 1, notice that we used the law of sines to find side lengths, lowercase b and lowercase c. And in problem number 2, we're going to use the law of sines to find angle measures, capital A and capital C. So notice the pair that we have. We have angle B and we have side B. So let's do b over the sine of b equals a over the sine of a. So that would be 6 over the sine of 26.4 equals 12 over the sine of a. So we cross multiply. There's going to be an extra step this time. Next, we're going to divide both sides by 6. But we don't have a by itself yet. We have the sine of a. And the way we undo sine is inverse sine. And that should make a whole lot of sense after having done chapter 4. Inverses undo one another. So back in geometry, when you learned about inverse sine, maybe it didn't really sink in that it was connected to anything else. But now we know that inverse undoes the regular function. So inverse sine undoes regular sine. So that's going to leave a by itself. If you use an inverse trig function, it helps you find an angle. If you use a regular trig function, you already know the angle. Okay, we put this in a calculator. And I'll remind you again, when it opens parentheses before the 26.4, be sure that you close them before you divide by 6. And it looks like 62.8 if we round to the nearest tenth. Okay, so now let's go through and use the law of sines again to find angle C. So it's going to look very similar. B over sine B equals C over sine C. So 6 over the sine of 26.4 equals 8 over the sine of C. You're going to cross multiply. You're going to divide by 6. And you could reduce 8 over 6, but since we're just going to be putting this in the calculator, it's not really going to matter if we do that step or not. And then we're going to isolate C by taking the inverse sine. Okay, and then from the calculator, 36.4 degrees approximately. So in that problem, we already knew 4 of the things. We knew all 3 sides and we knew 1 angle. So all we had to do is find the other 2 angles. But I want you to think about this for a minute. Look at what we have. We have angle B, 26.4 degrees, angle A, 62.8 degrees, angle C, 36.4 degrees, approximately. What do those add to? If we add the approximate values of those 3 angles, we get 125.6 degrees. That's a problem. We know the 3 angles of a triangle are supposed to add to 180 degrees, and we did not get 180. So that means that something went wrong. So I'll tell you what went wrong. Remember in the beginning of the lesson when we did this? There are 2 different angles that have the same sine value, an angle and its supplement. However, when you use your calculator to find the inverse sine of something, it's not going to give you both angles. So if you wanted to find the angle here or here, your calculator only gives you 40. It doesn't give you 140. So there are times when you solve a problem and the calculator gives you the smaller of the 2 angles and you actually wanted the larger. So Which angle here should be the largest? Well, in a triangle, the largest angle is across from the largest side. The smallest angle is across from the smallest side. So the largest side is 12, side A. The largest angle should be angle A. So that angle is the wrong one. That should actually be the supplement. So 180 minus 62.8. And that is 117.2. Okay, so how are we going to avoid this problem in the future? Well, I kind of forced this to happen to us by saying that we had to find both A and C using the law of sines. What you'll do in the future is, if you're missing two angles, you'll find the smaller one with the law of sines, and then you'll just subtract the two you have from 180 to get the third one. So if I were to do this problem all over again, I would start by finding the measure of angle C, and then I would find the measure of angle A by subtracting the other two angles from 180, and we would avoid this problem. So this is what it says. Be careful when using the law of sines to solve for the largest angle. If it is an obtuse angle, you will get the wrong answer on your calculator. Your calculator gives you the supplement of the obtuse angle you want. And by the way, there is a way to know if you have an obtuse triangle. If you take the three side lengths, and if you kind of apply the Pythagorean Theorem, so if you take the shorter two, 6 squared plus 8 squared, and if you get it to be less than the longer one squared, it is obtuse. If you get it to be greater than the longer one squared, it's acute. And if you get it to be equal to the longer one squared, it's right, which is the Pythagorean Theorem. Okay, I know this is going to be a long video, but I want to work through a couple more examples with you. Some of them are going to go pretty fast. Okay, in triangle ABC, we know angle B, we know angle C, we know angle A. Solve the triangle. Well, we can't. If you picture, this is not going to be drawn to scale, but if you picture a triangle with a 95-degree angle, a 40-degree angle, and a 45-degree angle, what is to stop me from, let's see if I can do this here. Oh, it's already grouped. What is to stop me from making it this triangle, or this triangle, or this triangle? There are infinitely many different triangles that have these angles, so there's no way to solve for a single answer. I know you guys like that example because it was short and you didn't have to write anything down. Number 4. Okay, suppose we know angle B, we know side A, and we know side C. Solve the triangle. Okay, well, we have a problem with this one too, because in order to use the law of sines, you would have to know A and A, or B and B, or C and C. We don't have enough information, so we can't solve the triangle. Sorry, if you were hoping that would take longer, it didn't. Number 5. Here we have two angles and one side. Now notice that we don't have a pair. We have angle B, angle A, and side C. However, because we have two angles, we can always find the third. C would be 180 minus 90 minus 30, so C would be 60. So we actually do have a pair. We have C and C. So we could use the law of sines. But because this one happens to be a right triangle, and it happens to be a 30, 60, 90 right triangle, we don't have to use the law of sines, and we don't have to approximate. We know the ratio of the sides of a 30, 60, 90 triangle. Let's see, the 90-degree angle was B, the 30-degree angle was A, and the 60-degree angle is C. Side C would be across from the 60. We know that the short leg, I'll call it X, when multiplied by square root 3 gives us the long leg 15. X times square root 3 equals 15. So x is 15 divided by square root 3. Let's rationalize that. We get 15 square root 3 over 3. Let's reduce that. It's 5 square root 3. And that would be side A. I should have called it A, maybe. So side A is 5 square root 3. And then the other side, B, is twice the short leg. So B is 2 times A. So B is 10 square root 3. So don't forget about those special cases and use your shortcuts on the special cases. Okay, we did make it through in about 20 minutes, so that's good. So I have 2 worksheets for you, the Law of Sines worksheet, and then I want you to keep practicing exact values, so I have a 3rd exact values practice worksheet for you. Thanks, everybody.